Thank you for watching our content. If you enjoy learning about the mysteries of space, don't forget to follow us for more cosmic wonders. Space, the final frontier, an infinite expanse of mystery and possibility. But how much do we really know about the universe beyond our world? What secrets lie in the vast distances between the stars? For centuries, humans have gazed at the night sky, wondering what lies beyond. And now, with advancements in technology and space exploration, we are finally beginning to unlock those secrets. Human curiosity about space has shaped our history in profound ways. Early civilizations, from the ancient Egyptians to the Greeks and Babylonians, closely observed the stars and planets, developing some of the earliest astronomical charts. These early stargazers laid the groundwork for modern astronomy. Greek scholars like Ptolemy and Aristotle imagined an Earth-centered universe, a view that held for centuries until the revolutionary work of Copernicus and Galileo in the Renaissance shifted our understanding, placing the Sun at the center of the solar system instead. It wasn't until the 20th century that humans physically left the Earth. The launch of Sputnik by the Soviet Union in 1957 marked humanity's first step into space, ushering in the dawn of the space age. This milestone sparked a fierce space race between the United States and the Soviet Union, leading to some of the most iconic achievements in human history. In 1961, Yuri Gagarin became the first human to orbit the Earth, and just 8 years later, Neil Armstrong took humanity's first steps on the Moon during NASA's Apollo 11 mission. These early successes were more than technological feats. They symbolized a leap toward understanding our place in the cosmos. Since those pioneering days, we've seen remarkable progress. The International Space Station, ISS, became a hub for international cooperation and research in space, orbiting 400 kilometers above the Earth. Mars rovers like Curiosity and Perseverance are scouring the surface of the red planet, searching for clues about ancient water and potential signs of life. Telescopes like the Hubble Space Telescope have provided us with stunning views of distant galaxies, nebulae, and black holes, offering a glimpse into the far reaches of the universe. But all of these achievements have only given us a glimpse of the vastness of space. The observable universe stretches about 93 billion light-years across. That's just the part we can see, and the universe could be much larger, perhaps even infinite. But what's even more mind-boggling is that this vast expanse is not static, it's expanding. And not just at a steady rate. This expansion is actually speeding up. This acceleration is being driven by an unseen force that scientists call dark energy. It's thought to make up about 68% of the universe, yet we don't understand what it is. Unlike gravity, which pulls objects together, dark energy seems to push the universe apart, increasing the distance between galaxies. The concept of dark energy is one of the biggest mysteries in cosmology. How can something so influential be so elusive? What exactly is it, and how does it work? These are questions that researchers are still struggling to answer. The problem is we can't directly observe dark energy. We can only infer its existence through its effects on the universe. To study dark energy, scientists rely on observations of distant supernovae and cosmic microwave background radiation, essentially the afterglow of the Big Bang. These observations show us that the universe's expansion is speeding up, but they still don't explain why. Solving the dark energy puzzle may require a new understanding of physics, one that goes beyond our current theories. Even as we explore these cosmic mysteries, our ambitions in space continue to grow. Plans to return humans to the Moon through NASA's Artemis program are well underway, with an eye toward establishing a permanent presence on the lunar surface. Meanwhile, private companies like SpaceX are developing new technologies that could take humans to Mars within the next decade. We're also working on groundbreaking missions like the James Webb Space Telescope, which promises to unlock even more secrets of the universe, allowing us to peer deeper into space and further back in time than ever before. As we continue our exploration of space, one thing is clear. We're only at the beginning of our journey. The discoveries we make in the coming years will change not only what we know about the universe, but also what we know about ourselves. Space offers endless possibilities, and the more we learn, the more we realize how much more there is to discover. The universe is unimaginably vast. When you look up at the night sky, the stars you see are only a tiny fraction of what's really out there. In our Milky Way alone, there are over 100 billion stars, and that's just one galaxy out of trillions. Let's start with stars, the building blocks of galaxies. A star is essentially a massive, glowing ball of gas, primarily hydrogen and helium, undergoing nuclear fusion. This fusion process releases tremendous amounts of energy, which is why stars shine. But stars are more than just twinkling lights. They are the powerhouses that create the elements necessary for life. Through a process called nucleosynthesis, stars fuse lighter elements like hydrogen into heavier ones, including carbon, oxygen, and even iron, elements that eventually form planets and living beings. Stars come in many types and sizes, from small, dim red dwarfs that can burn for trillions of years, to massive blue giants that explode in spectacular supernovae after just a few million years. Our own sun is a yellow dwarf, a medium-sized star that's been burning for about 4.6 billion years and has enough fuel to keep going for another 5 billion years. But there are stars out there that are much more massive, and when they reach the end of their life cycle, they collapse into neutron stars or black holes. Our solar system is located in the Milky Way, a spiral galaxy with distinct arms that swirl around a dense core. It's estimated to be about 100,000 light-years in diameter, meaning if you traveled at the speed of light, it would take you 100,000 years just to cross our galaxy. In the center of the Milky Way lies a supermassive black hole, known as Sagittarius A*, which has a mass 4 million times greater than our Sun. As vast as the Milky Way is, it's just one of an estimated 2 trillion galaxies in the observable universe. Galaxies come in different shapes: spiral, elliptical, and irregular. Spiral galaxies, like the Milky Way, have well-defined arms. Elliptical galaxies, on the other hand, are more spherical and tend to contain older stars. Irregular galaxies have no specific shape and are often the result of galactic collisions or other disturbances. It's easy to think of space as a vast, empty void, but there's much more out there. Between stars, we find massive clouds of gas and dust, the raw material from which new stars and planets form. These regions, known as nebulae, are often the birthplaces of stars. But beyond gas and dust, there's something even more mysterious filling the universe: dark matter. Dark matter makes up about 27% of the universe, yet we can't see it, touch it, or directly detect it. We only know it exists because of the gravitational effects it has on visible matter. For example, galaxies spin faster than they should, based on the amount of visible matter they contain. Scientists believe this extra, hidden mass is dark matter. Even more fascinating is the idea that galaxies and clusters of galaxies are connected by a vast cosmic web of dark matter, forming the largest structures in the universe. Galaxies aren't static. They move and even collide with one another. When galaxies merge, their stars don't typically crash into each other because of the vast distances between them, but their gas clouds collide, triggering bursts of star formation. In about 4.5 billion years, our own Milky Way is expected to collide with the neighboring Andromeda galaxy, creating an entirely new, larger galaxy. The more we explore the universe, the more we realize how truly vast and interconnected everything is. From the individual stars that create the building blocks of life to entire galaxies woven together by dark matter, the universe is a complex and awe-inspiring place. And yet, we've only just begun to scratch the surface of understanding the true nature of the cosmos. A vast frontier of undiscovered worlds. These are exoplanets, planets that orbit stars other than our Sun. To date, we've confirmed the existence of over 5,000 exoplanets, and astronomers believe there could be trillions more out there, waiting to be found. An exoplanet is simply any planet outside our solar system. They come in a variety of forms. Some are gas giants like Jupiter, others are small and rocky, like Earth. The discovery of these planets has revolutionized our understanding of planetary systems and raised an exciting possibility that many exoplanets could harbor life. Detecting exoplanets is challenging because they're so far away and don't emit their own light. But astronomers have developed clever methods. One of the most common techniques is the transit method. This involves observing a star's brightness over time. When an exoplanet passes in front of its star, it causes a tiny dip in brightness, signaling the presence of a planet. Another method is radial velocity, which measures the subtle wobble of a star caused by the gravitational pull of an orbiting planet. One of the most thrilling aspects of exoplanet discovery is the potential for finding life. Astronomers focus on planets that orbit in the habitable zone, the region around a star where conditions might be just right for liquid water, a key ingredient for life. We've already discovered Earth-like planets in these zones, sparking hopes that life could exist elsewhere in the universe. Exoplanets are incredibly diverse. Some are super-Earths, rocky planets larger than Earth but smaller than Neptune. Others, known as hot Jupiters, are gas giants that orbit very close to their stars, reaching temperatures of thousands of degrees. There are even rogue planets, which don't orbit any star at all, drifting through the galaxy on their own. NASA's James Webb Space Telescope and the Transiting Exoplanet Survey Satellite, TESS, are revolutionizing our search for exoplanets. These tools allow us to study exoplanet atmospheres in unprecedented detail. By analyzing the light that passes through an exoplanet's atmosphere during a transit, scientists can identify the presence of gases like oxygen, methane, and water vapor, possible signs of life. Biosignatures are chemical signs of life, and scientists are working hard to identify them on distant exoplanets. Finding even the faintest trace of oxygen or methane could be a game changer in our search for extraterrestrial life. Imagine discovering that we're not alone in the universe. What would that mean for humanity? As our technology improves, so will our ability to explore these distant worlds. In the coming decades, we may find habitable planets and even signs of life far beyond our solar system. Exoplanets offer a tantalizing glimpse into the universe's vast diversity, and who knows what amazing discoveries lie ahead. Next, we will talk about the mind-bending phenomenon of time dilation and black holes. Time, something we think we understand, doesn't behave the same way everywhere in the universe. Thanks to Einstein's theory of relativity, we now know that time is not constant. It can stretch and warp depending on speed and gravity. This mind-bending concept is known as time dilation. Let's break it down. According to Einstein's theory of relativity, time is relative. It can flow differently depending on where you are. This happens in two ways, through speed and gravity. When you travel at speeds close to the speed of light, time actually slows down for you compared to someone who is stationary. This is called special relativistic time dilation. The faster you go, the slower time moves for you relative to someone back on Earth. Imagine traveling on a spaceship at 99% of the speed of light. If you spent just a few years on your journey, decades, or even centuries might pass on Earth. You would return home to find that while you've only aged a few years, everyone else has grown old. This isn't just science fiction. It's a real consequence of the laws of physics. But time can also slow down due to gravity. This is called gravitational time dilation. The stronger the gravitational pull, the slower time moves. Nowhere is this effect more extreme than near a black hole. A black hole's gravity is so intense that it warps space and time itself. If you were to approach a black hole and hover just above the event horizon, the point beyond which nothing can escape, time would slow dramatically for you. While just hours pass near the black hole, centuries could pass for someone observing you from a distance. So, what happens beyond the event horizon of a black hole? That's one of the biggest mysteries in astrophysics. Inside the event horizon, space and time become so distorted that the known laws of physics break down. Some scientists believe that a singularity, a point of infinite density, lies at the center of every black hole, where space and time collapse. There's also a fascinating theory that black holes could be gateways to other parts of the universe, or even to other dimensions. This idea is linked to the concept of wormholes, theoretical tunnels through space-time that could connect distant points in the universe. If wormholes exist, they could provide shortcuts through space and even allow for time travel. While this remains purely theoretical, it's an exciting idea that continues to inspire both scientists and science fiction writers. Time dilation doesn't just happen in space. It affects us here on Earth too, although the effects are much smaller. For example, astronauts on the International Space Station experience time dilation because they're moving so fast around Earth. In fact, astronauts age just a tiny bit slower than people on Earth. And GPS satellites, which orbit the Earth, have to account for time dilation due to both their speed and weaker gravity. The deeper we explore the universe, the more we realize that time is far more complex than we once thought. Time dilation near black holes, the potential for wormholes, and the strange behavior of time at extreme speeds challenge our understanding of reality. As we continue to study these phenomena, we may one day unlock the secrets of time itself, and perhaps even learn how to bend it to our will. Now, we will talk about wormholes, theoretical gateways through space and time. Imagine a tunnel through space-time, a shortcut that could take you to distant parts of the universe instantly. This is the fascinating concept of wormholes. Though purely theoretical, wormholes have captured the imaginations of scientists and science fiction fans alike. So, what exactly is a wormhole? It's a solution to the equations of Einstein's theory of general relativity. In simple terms, a wormhole is a tunnel that connects two distant points in space-time. Think of it like a shortcut between two locations in the universe. Instead of traveling across space at the speed of light, a wormhole could theoretically allow you to hop between distant galaxies in an instant. But here's the catch. Wormholes are incredibly unstable. The moment something tries to pass through them, they collapse. In order to keep a wormhole open long enough for travel, you would need a special type of exotic matter with negative energy, which we haven't yet discovered. However, the idea of traversable wormholes that remain open long enough for travel, is still a major area of research in theoretical physics. One of the most exciting possibilities that comes with wormholes is the idea of time travel. If a wormhole connects two different points in time, traveling through it could allow you to journey to the past or the future. While this idea sounds like something straight out of science fiction, it's a real possibility that physicists have considered. Wormholes are also linked to the study of black holes. Some scientists believe that black holes could be connected to wormholes, acting as the entrances to these cosmic tunnels. While we have no observational evidence of wormholes existing, they remain a compelling solution to some of the mysteries of space-time. The biggest challenge, however, is making wormholes stable. To date, we've never observed a wormhole in the real world, and the exotic matter needed to keep them open might not even exist. Furthermore, even if wormholes did exist, navigating through one could be extremely dangerous due to the intense gravitational forces at play. Wormholes have long been a favorite topic in science fiction, from movies like Interstellar to television series like Star Trek. These fictional stories explore the possibilities of faster-than-light travel, time loops, and even alternate dimensions. While wormholes remain theoretical, the excitement they generate continues to inspire both storytellers and scientists. As we continue to push the boundaries of our understanding of space and time, wormholes represent one of the most intriguing and mind-bending possibilities in physics. While we may be far from using them for space travel or even proving their existence, the idea of wormholes offers a tantalizing glimpse into the future of exploration and discovery. Now, we will talk about the search for extraterrestrial life. The question of whether we are alone in the universe has fascinated humanity for centuries. With billions of planets across billions of galaxies, the possibility of life beyond Earth feels more real than ever. Today, we'll explore the search for extraterrestrial life and how close we are to answering one of humanity's greatest mysteries. Scientists begin by searching for planets that orbit in the habitable zone, the region around a star where conditions might be just right for liquid water to exist. Water is essential for life as we know it, so finding planets with the potential for liquid water is the first step. These planets, sometimes referred to as Goldilocks planets, aren't too hot or too cold, making them prime candidates for hosting life. We've already found intriguing possibilities for life close to home. Mars, for instance, shows evidence of ancient water flow, and its underground reservoirs could still harbor microbial life. But it's not just Mars. Moons like Europa, orbiting Jupiter, and Enceladus, orbiting Saturn, both have vast oceans beneath their icy surfaces. These hidden oceans could provide the perfect conditions for life to thrive. Outside our solar system, the search for life turns to exoplanets, planets that orbit stars other than the Sun. In recent years, we've discovered thousands of exoplanets, and some of them are located in the habitable zone of their stars. Tools like the James Webb Space Telescope and the Transiting Exoplanet Survey satellite tests are helping us study these planets in greater detail than ever before, analyzing their atmospheres for potential biosignatures. Biosignatures are chemical signs that life might exist. For example, the presence of oxygen, methane, or water vapor in an exoplanet's atmosphere could be a strong indication that life exists there. Finding even the faintest trace of these elements would be a game changer in the search for life beyond Earth. There's also the ongoing search for extraterrestrial intelligence, or SETI. This project scans the sky for signals from advanced alien civilizations. SETI researchers listen for radio signals that might be coming from distant planets, hoping to catch a message from intelligent beings. While we haven't yet found definitive proof of intelligent life, the search continues, and it's only a matter of time before we find something extraordinary. Discovering life beyond Earth would be one of the most profound moments in human history. Even finding microbial life on another planet or moon would change our understanding of biology, evolution, and our place in the universe. It would raise new questions about how common life might be and whether intelligent civilizations are out there, waiting to be discovered. With every new discovery, we're getting closer to answering the age-old question: are we alone in the universe? As our technology improves and our exploration continues, the possibility of finding life beyond Earth feels more real than ever. The search for extraterrestrial life is only just beginning, and who knows what we might find in the years to come. Now, we will talk about the Fermi paradox, a question that has puzzled scientists for decades. With billions of stars and potentially habitable planets in the universe, why haven't we found any evidence of extraterrestrial life? Today, we'll explore the mystery behind the Fermi paradox and consider the many possible explanations. The Fermi paradox asks a simple but profound question. If the universe is so vast, ancient, and filled with billions of stars and planets, where is everyone? Why haven't we seen any evidence of advanced civilizations or even simple forms of life beyond Earth? Statistically, it seems improbable that Earth is the only planet with intelligent life, yet we found no concrete proof that life exists elsewhere. Consider this. There are about 100 billion stars in our galaxy, the Milky Way, and each of those stars could have planets. In fact, scientists estimate that there are around 6 billion Earth-like planets just in our galaxy. Multiply that by the estimated 2 trillion galaxies in the observable universe, and the number of potential homes for life becomes staggering. The odds seem overwhelmingly in favor of life existing somewhere else. So why haven't we found any evidence yet? There are many theories to explain this paradox. One of the simplest explanations is that intelligent life is incredibly rare. Perhaps Earth is a statistical anomaly, a planet where the right conditions came together to allow intelligent life to evolve. This could mean that while microbial life might be more common, intelligent civilizations like ours are extremely scarce. One of the most discussed theories is the Great Filter. This idea suggests that there is a kind of bottleneck or obstacle that prevents life from evolving past a certain stage. This filter could occur early, meaning that the leap from simple to complex life is extremely difficult and rare. Or the filter could occur later, suggesting that while intelligent civilizations might evolve, they tend to destroy themselves before they can expand beyond their home planet. This raises a chilling possibility. If the Great Filter is ahead of us, it could be a warning about humanity's future, Another explanation for the lack of contact is the sheer size and age of the universe. The universe is 13.8 billion years old, and intelligent civilizations may have risen and fallen long before we appeared. Even if there are other civilizations out there, the vast distances between stars mean that communication could take millions or even billions of years to reach us. It's also possible that civilizations are so far apart that they've never had the opportunity to interact. Some more speculative theories have been proposed as well. The zoo hypothesis suggests that advanced civilizations know about us, but choose to observe from afar without interfering, similar to how humans observe animals in a zoo. In this scenario, they might be waiting for humanity to reach a certain level of development before making contact. Another possibility is that alien civilizations are communicating, but in ways we don't yet understand. They might use technologies or signals that we haven't discovered or don't have the capability to detect. There's also the intriguing possibility that extraterrestrial life exists, but in forms that we simply don't recognize. Life elsewhere could be based on entirely different chemical processes or exist in environments we wouldn't consider habitable, like deep within gas giants or in the extreme temperatures of stars. Our search has been biased by what we know about life on Earth, but life in the universe could be far more diverse and complex than we can imagine. Despite the lack of evidence so far, our search for extraterrestrial life is just beginning. Advanced projects like the James Webb Space Telescope will give us a clearer view of distant planets, while initiatives like SETI continue to listen for signs of intelligent civilizations. It's possible that we're simply looking in the wrong places or using the wrong methods, and that groundbreaking discoveries are still ahead. The Fermi paradox highlights the contradictions between the probability of life in the universe and our lack of evidence for it. As our technology improves and our exploration of the cosmos deepens, we may one day solve this mystery. Until then, the question of where is everyone continues to challenge our understanding of life, intelligence, and the universe itself. Now, we will talk about the future of space exploration, how humanity is preparing for its next giant leap, returning to the moon and sending humans to Mars. The moon has long been a symbol of humanity's desire to explore space. In 1969, we took our first steps on its surface, but since 1972, no human has set foot there. That's about to change. NASA's Artemis mission aims to return humans to the moon by 2025, with the goal of establishing a permanent presence on the lunar surface. This isn't just about exploration. It's about learning how to live and work on another world. So, why return to the moon? The moon offers an ideal testing ground for the technologies we'll need to explore other planets. It's much closer than Mars, making it a perfect place to practice long-duration space missions. By establishing a lunar base, we can test life support systems, habitats, and resource extraction techniques, skills that will be crucial when we eventually set out for Mars. Private companies like SpaceX are also playing a key role in the future of space exploration. SpaceX's Starship is being developed as a reusable spacecraft capable of carrying large crews and cargo beyond Earth's orbit. Starship will be used not only for NASA's Artemis mission, but also for potential missions to Mars. This collaboration between public space agencies and private companies represents a new era in space exploration, where innovation and competition are driving rapid advancements. While the moon is a critical step, Mars is the ultimate goal. Mars has fascinated scientists and explorers for decades because it's the most Earth-like planet in our solar system. NASA's goal is to send humans to Mars by the 2030s. The mission will be incredibly challenging. A round trip to Mars could take up to 3 years, and astronauts will need to be self-sufficient, relying on resources found on Mars, such as water and minerals, to survive. To make Mars exploration possible, new technologies are being developed. This includes advanced spacecraft, habitats that can sustain life for long periods, and systems to produce water, oxygen, and even food using Martian resources. The idea is to create a closed-loop system where astronauts can generate everything they need to survive, reducing their dependence on supplies from Earth. But it's not just about human exploration. One of the biggest questions about Mars is whether life ever existed there. The Perseverance rover, currently exploring the Martian surface, is searching for signs of ancient microbial life. If we find evidence of life on Mars, it would revolutionize our understanding of biology and the potential for life elsewhere in the universe. Looking further ahead, some experts believe that humans could one day colonize Mars, using the planet's resources to build sustainable communities. While this may sound like science fiction, the technologies being developed today are laying the groundwork for a future where humans live on multiple planets. The idea of becoming a multiplanetary species isn't just about adventure. It's also about ensuring the long-term survival of humanity. The future of space exploration is bright. With missions planned to the Moon and Mars, we are on the verge of a new era in human exploration. The next few decades will be critical in determining how far we can go and whether humanity's future lies beyond our home planet. As we look to the stars, we are reminded that the next giant leap is just around the corner. And who knows what incredible discoveries await us. Thank you for watching. If you enjoy our content, don't forget to follow us and like our video. Your support helps us continue exploring the mysteries of the universe and bringing exciting discoveries to you. Stay tuned for more, and keep looking up